Regarding the return cycle, the orogenic belt is mainly formed by the inversion of rifted margins. From this observation results one question: how reef-related inheritance drives the fate of orogenic systems? One approach to address this question consists in describing and restoring reef architectures from the fossil remnants preserved in mountain belts. Hi everybody, my name is Maxime DUCOUX, and during my postdoctoral position I try to answer this question by describing the former rifted template of the Pyrenean belt. It is a good example actually because, firstly, this belt results of the inversion of a series of hyperextended rift basins, and secondly, it is associated with an efficient pre-rift decoupling layer corresponding to the upper Triassic salt that play a significant role during rifting and convergence. As most of salt-bearing hyperextended rift basins were strongly overprint during Pyrenean shortening, we decided to focus our work on the western Pyrenean basins relatively preserved from pervasive orogenic deformations. To recognize the former distal domain, we used the Basque-Cantabrian basin. By combining structural and thermal data, we show that the decoupling layer is responsible, firstly, of the juxtaposition of the basin on top of the exo mantle, which led the high temperature metamorphism, and secondly, the early structure of the basin itself, with the development of salt ridge and mini basins, just tightening during the inversion. Concerning the former necking domain, we use the Arzac basin, which benefits from 1 century of oil and gas exploration that providing numerous drill hole data associated with a good 2D and 3D reflection seismic coverage. By mapping the top basement horizon, we show that the Arzac basin, ambiguously described as a sac basin, consists of an asymmetric extensional syncline actually, filled by thin reef sediments and controlled by a basement-involved low-angle, long-offset normal fault decoupling into a preclimatic upper Triassic salt. By using the results of the Arzac basin, we show that the decoupling layer plays a significant role for the resulting fault structure and basin architecture, as well as the partitioning of the deformation between the basement and the overburden. To resume, this schematic figure represents the former reef system of the Pyrenean belt and shows the distribution of the necking and hyperextended domain previously described. Now, considering our work previously described, we propose an interpretation for the inversion of a hyperextended reef system. In the case of Eastern Pyrenees, we use distribution of the metamorphism to show that the hyperextended rift domain is firstly reactivated and thrusted on top of necking domain up to the collision of both margins. This model highlighted the alloctonous position of this unit. To conclude, from this experience, we are currently trying to apply this method in the Oman mountain belt to unravel its overprinted rifting template. And if you have any questions or if you want more information about our work, you can consult published and future published articles or contact me with this mail address. Thank you very much. Bye.